Welcome grade 10 math students to our first video tutorial. Today's lesson is on an investigation of transformations of parabolas. So today we are going to learn how parabolas move around the coordinate grid. How they move left, right, up, down, and even how they can be reflected in the x-axis, meaning that they are flipped upside down. So today we're going to learn how all of that occurs. For this lesson, what you will need is the investigation handout that we went through in class. It looks like this. It has three parts to the investigation. Here's the first part. Investigation 1, comparing y equals x squared to y equals x squared plus k. Investigation 2, comparing y equals x squared to y equals x minus h squared. And investigation 3, comparing graphs of y equals x squared and y equals ax squared. Also what you'll need is this placemat here. I'll try and zoom out so you can see it better. You will need this placemat where we will collect all of our ideas into one single area, and it'll be a nice reference for you when we're working with quadratics in vertex form. Okay, so make sure you have that with you while you're following along with this lesson. Hopefully you can use this tutorial as an aid for you if you just need some clarification of concepts that we did in class, or if you missed the class, hopefully you can use this to follow along and fill out the investigation. So, up until now in the unit, when we've looked at quadratics, they have been in standard form. So standard form is this right here. Y equals ax squared plus bx plus c. Up until now, all the quadratics we've seen have been in that form. In order to graph a quadratic in that form, we had to make a table of values, and then plot all the points, and then draw the parabola, and it took quite a bit of time. Today we're going to learn about quadratics in this form, in y equals ax minus h squared plus k. What we're going to do is spend some time figuring out what the values of a, h, and k mean. Okay, what do they stand for? When we change these values, how is the parabola going to be affected? We know in an equation, so our equation is, y equals ax minus h squared. Excuse the writing, I know it's not the greatest. So our equation is y equals ax minus h squared plus k. Okay? We know that x and y stand for the coordinates of all the points on the parabola. Okay? That's what x and y always stand for for the equation of any function. They stand for the coordinates of the points of that function. What we're going to look at now is figuring out what ah and k stand for, and once we've figured that out, we'll understand why it's useful to represent a quadratic in this form. Okay? Why is it useful to represent a quadratic in vertex form opposed to standard form? So we'll try and figure that all out through this investigation. So before we start the investigation, it would be useful just to do a quick review of what we know about parabolas so far. So the most basic quadratic function is y equals x squared. This is the graph of y equals x squared. It's a rough graph, it's not the exact graph, but what's important to note here is two things. The first, that the vertex of the parabola is right here. And we learned that the vertex of a parabola is the maximum or minimum point of the parabola. In this case, the vertex is the minimum point because the parabola opens up. As we increase x values, the y values are going to decrease until it gets to that vertex. Then as we continue to increase the x values, the y values to the right of the vertex will then start to increase. Okay? So this parabola will never go below this point right here. That is the minimum value. So in this case, the vertex is a minimum value. The vertex of this parabola, because it's at the origin, is 0, 0. Now, let's remember what the axis of symmetry is. The axis of symmetry, if we remember back to our definition, is a vertical line. Oh, sorry, that's not completely straight, but it's a vertical line that passes through the vertex of a parabola. Okay, and the axis of symmetry is like a mirror for this parabola. It's symmetrical on either side. Okay, so this side of the parabola is symmetrical to this side, and the axis of symmetry you can think of as the mirror. Now, the equation for the axis of symmetry is x equals 0. Why that is because for this vertical line, the x values of all the coordinates on that line are going to be 0. This line doesn't move left or right at all. It's completely vertical. Okay, so every x value on that line is x equals 0. Therefore, the axis of symmetry is x equals 0. A nice little trick, in order to determine your axis of symmetry, just look at the x coordinate of your vertex, and that will be your axis of symmetry. Good. Now let's move on to the first part of our investigation. So right now, make sure you have your investigation out, and you are looking at investigation 1. Compare the graphs of y equals x squared and y equals x squared plus k. So for this part of the investigation, we don't want to be considering, if we look back to our vertex form of parabola, it's right here, y equals ax minus h squared plus k. We want to figure out what k does. So we don't want to consider h or a at this point. So what we are going to do in order to make that happen, let me just rewrite our equation here. So equation of our parabola is y equals ax minus h squared plus k. We only want to figure out what varying the value of k does to the parabola. In order to do that, we are going to set a to equal 1. That way we're just multiplying the parabola by 1. And set h to equal 0. That way we're not taking anything away from the x. If we simplify this equation, you will notice that we just get x squared plus k. So now when we vary the values of k, we'll be able to determine how that affects the parabola. So let's go ahead and do that. So if you have a graphing calculator, get that out now. If you don't, it would be useful for you to download one. Here's an example of a graphing calculator emulator that you can get online from texasinstruments.com. It's fast and easy to download, and it'll make your work at home a lot easier. So remember, when you have your graphing calculator, your first step is to clear all the memory on there. So you're going to go second plus 7, 1, 2. And that'll become very habitual for you as you use it more. Okay, so the first thing we want to do is look at how the graph of y equals x squared plus 3 compares to the graph of y equals x squared. I have the graph of y equals x squared on the grid here, and it's drawn in black. So now let's look at how y equals x squared plus 3 relates to that. In order to do that, we're going to go into our calculator and input into the y1. So the first function, we're going to input x squared. Just so we have our graph of y equals x squared on there. Let's take a look. Yep, there it is. Now let's scroll down to our second function and input x squared plus 3. And let's see how that compares. Oh, and you'll notice that the parabola has moved up 1, 2, 3 units. So on your investigation, you are going to want to roughly sketch that parabola, and it should look something like this. So it's going to move up 1, 2, 3. Let's try and make this a little more exciting with how these parabolas move. Let's put some sound effects in here. Okay, so we have, oh, I moved my grid by accident. Okay, so we have y equals x squared, and then if we have y equals x squared plus 3, it's going to move up 1, 2, 3 units on the y-axis. Awesome. So we can kind of understand why that happened it didn't just move arbitrarily up 3 units. If we look at our equation, we have x squared plus 3. So after we've done that one function, we've graphed it, we might want to try and make an inference that maybe altering this k value moves the parabola up. So if that k value is 3, it moved up 3. So now we might want to think if our k value is 5, we kind of infer that maybe the parabola will move up 5. If we use our graphing calculator to verify that, go into our, turn it back on. We input a third function, y equals x squared plus 5. If we graph that, we will notice that the parabola has now moved up 1, 2, 3, 4, 5 units. Awesome. So if we put this parabola on our graph here, it will look like this. It'll move up 1, 2, 3, 4, 5. And there's the graph of that parabola. So make sure you have that sketched on your investigation. Now next, if on our graphing calculator we input x squared minus 2, what do you think will happen? When we had a positive k value, it moved up. So you might think that when we have a negative k value, the parabola might move down. Let's take a look if that happens. If we brought up our graphing calculator here, let's clear our second function, and let's put in x squared minus 2. We graph that. You'll notice, yes, indeed, the parabola did move down too. So instead of those jumping sound effects for going up, let's use the sewer sound effects for going down, because that makes sense to me. So it goes down 1, 2. Good. So there's the parabola there. And if we did the same thing for x squared minus 4, put it in our graphing calculator, we would determine that this parabola goes down 1, 2, 3, 4. Good. So these are all the parabolas you should have sketched on your investigation. After you have those sketched, what you also need to fill out, I'll bring it up here to show you and I'll zoom in. What you also need to fill out is what the vertex of each of these parabolas are, the axis of symmetry, direction of opening, maximum or minimum value, and the relation to y equals x squared. For the first example here, I'll take you through and explain to you how you did it. You'll be responsible for filling out the rest on your own. The answers are posted on first class, so you can go through and check and make sure you're doing it properly. Okay, so for y equals x squared plus 3, the parabola moved up 1, 2, 3 units. So the vertex, the y value of the vertex has increased by 3. The parabola hasn't moved left or right on the x-axis at all, so the x-coordinate of the vertex has stayed at 0. So our vertex, that point right there, is 0, 3. Our axis of symmetry, the vertical line that passes through the vertex, is x equals 0. Look at the value of the x-coordinate of your vertex, and that is your axis of symmetry. The parabola opens up, therefore it has a minimum value. This parabola will never go below that vertex. Okay? It will continue upwards forever, but it will never go below that point. And the minimum value, if we look at the y value of our vertex, the minimum value is y equals 3. Compared to y equals x squared, this parabola is up 3. The vertex has shifted up 3. Good. Okay. So remember, as we're going along through the lesson here, keep filling in this, pause the video, and make sure you're able to fill out this information, and check the posted answers and make sure you're getting it right. So you always want to be filling in all of these cells for the rest of the investigation. So I'll minimize that. And now let's summarize what we've learned about K. So K represents the vertical translation, because when we varied the value of K, the parabola's moved up or down. Okay? So it moved vertically. So K represents the vertical translation. If K is greater than 0, so when K was positive 3 or positive 5, the parabola's moved up. So if k is greater than 0, the graph is translated k units up. When k was less than 0, the graph is translated k units down. So you want to be filling this information out on your placemat, which you will be able to reference throughout this unit. So you want to be filling this out. The bottom left section, if we rotated this, it would be the bottom left section of your placemat. You want to be filling out that information. Okay, now let's move on and determine what varying the value of h does to a parabola. Remember what our vertex form of our parabola looks like. It's y equals ax minus h squared plus k. Now we are going to be looking at h. How does varying h affect the parabola? We've already determined k. Now let's determine h. Went too far here. Good. Okay. So, once again, if you bring up your graphing calculator, if we put y equals x minus 1 squared into our graphing calculator, turn it back on. Leave y equals x squared in your graphing calculator. That way you can compare it to our new graph. So let's make sure you leave your brackets in. So bracket x minus 1 to the exponent of 2. If we don't have our brackets, the calculator will only square the 1. It won't know to square that whole function. So we want to have the brackets in there, so it's bracket x minus 1 to the exponent of 2. Okay? If we graph that, we will notice, the parabola moved 1 unit to the right. So let's do that here. So here's our original parabola. Let's find some sound effects for that. So if it goes to the right, let's use this one. You keep with the Mario theme. And move 1 to the right. You might have thought when you saw a negative value here, when you saw like x minus 1, you might have thought it would have moved to the left. Because usually left and down are paired together and right and up are paired together. But we'll find out in a minute as to why this happens. So let's then look at the graph of y equals x minus 3 squared. If we put that in our calculator, you would see that it moves 1 unit, 2 units, 3 units to the right. So there's the graph of y equals x minus 3 squared. Also, if we then put y equals x plus 2 squared into our graphing calculator and graphed it, we would find that it moves 2 units to the left. 1, 2 units to the left. And then at this point, you can probably see the trend. Y equals x plus 3 squared is going to move 3 units to the left. 1, 2, 3. So those are all the graphs that you should have drawn on your investigation handout. At this point, take the time to fill out the rest of the cells about what the vertex is, the axis of symmetry, direction of opening, maximum or minimum values, and its relation to y equals x squared. So make sure you have all of that filled out. Now, let's take a look at what we've learned about the properties of the h value. Okay, so h represents the horizontal. Translation. Now, this is where it's going to get a little bit confusing and tricky, but we'll work it out. So, if h is greater than 0, the graph is translated h units to the right. Now, you might be saying, hold on, Mr. Jensen. When we had x minus 5, it moved to the right. And isn't h a negative value in that instance? And what I would say is no. H is actually a positive value. If we look back at our graph of y equals x minus 1 squared, okay, the h value in this instance is actually just the 1, okay, because let's try and write this out a little clearer so it makes more sense. Okay, so we have y equals x minus h squared. If I have an h value greater than 0, so an h value of 1, let's say, if I plug in that 1 for h, if I plug in that positive 1 for h, so I just get rid of the h, and I just plug in positive 1, it's going to appear like this. It's going to appear as 1 is being subtracted from x. And we discovered in our investigation that moves it to the right. So that positive 1 value of h moves the parabola to the right. Now let's find out what happens if we have a negative value of h. Okay, let's put h back in here. Okay, so here's the general equation. If I replace h with a negative number, so just get rid of the h, I can move this so I have room for the rest of the brackets. So I'm just replacing h with negative 1. Okay, now you'll notice how it's going to appear. When we subtract a negative, that becomes addition. So it's going to appear like this. It's going to appear as addition when we input a negative h value. When we figured out in our investigation, then when we have x plus 1 squared, it's going to move to the left. So that means when the h value is negative, right there, we can see that negative sign. When the h value that we plugged in is negative, it's going to move to the left. Okay? Make sure you understand this. This is the trickiest part of vertex form. Oh, I'm going to write that better. So if you need clarification on this, please rewind the video and go through what I've just said again. And if you need further clarification, leave some comments, message me, and we can go over it again. Okay, so just to summarize what h does, h is the horizontal. You can remember that by, h is the first letter in horizontal. If h is greater than 0, the graph moves h units to the right. But remember, it will appear as x minus 3. But remember that h value is just the 3. So the h value is actually positive in that instance. If the h value is less than 0, the graph moves to the left. We know that x plus 2 moved to the left. The h value is actually negative 2 in this instance. Okay? Now, so you filled this out on your placemat. Now the last one we have to consider is the a value. Okay? We've looked at, if we go back to our original equation in vertex form, which is y equals a x minus h squared plus k. We know k is the vertical translation. H is the horizontal translation. Now, what do we think varying the value of a will do? Let's go and take a look and find out. Okay, so if we put on our graphing calculator, if we put in y equals 2x squared, you would find out that the graph looks something like this. You will notice that it is narrower than the graph of y equals x squared. That's interesting. So when we put y equals 4x squared into our graphing calculator, so the a value is now 4, it looks something like this, even narrower than y equals 2x squared. Now on our graphing calculator, if we put in y equals negative x squared, the parabola will look like this. It'll rotate like this, and its vertex will still be at the origin. So what we call that is a reflection in the x-axis. Let's move all these other graphs out of the way for a second. So we have the graph of y equals x squared, and this is the graph of y equals negative x squared. So the only difference between these two graphs is that y equals negative x squared has been reflected in the x-axis. You can think of that x-axis as the mirror. Okay? So reflected in the x-axis is the technical way of saying that the parabola is flipped upside down. Okay? Let's put these ones back on. So when we have the graph of negative 2x squared, if we put that in our calculator, we find out that it is reflected in the x-axis, and it's also made narrower. Now the technical term for being made narrower is called a vertical stretch. Okay? You can think of someone grabbing the tops of the parabola here and kind of pulling them up so that it makes the parabola narrower. So it's called a vertical stretch. Okay? So if we fill out, oh, let's move on. There's still more a values we have to consider. Okay? So make sure for these first 4 graphs you have these sketched on your investigation, and you filled out all the accompanying cells about the vertex and axis of symmetry and so on. Okay, let's look at other a values. So when we had a values greater than 1 or less than -1, we saw that it stretched the parabola. Now let's look at when we have fractions of values between 0 and 1 or between 0 and -1, how that affects the parabola. How it's going to affect the parabola, if we use our graphing calculator and graph them, we will see that y equals 1 over 2x squared looks something like this. Okay? It looks wider than the graph of y equals x squared. And if we graphed y equals 1 over 8x squared, it would look even wider. Remember, 1 over 8 is a smaller number than 1 over 2. Okay, it's closer to 0. So the closer that fraction gets to 0, the wider this parabola is going to get. Now, and we remember what happens when the a value is actually negative. Oh, sorry, that should say y equals -1 over 2 x squared. Okay, good. Okay, so we're going to have the graph of y equals -1 over 2x squared. We know it's going to be reflected in the x-axis because the a value is negative. How that's going to look? It's going to look just like 1 over 2x squared, but it's going to be upside down. It's going to be reflected in the x-axis. I hope that looks close enough. And now y equals -1 over 4x squared, also going to be reflected in the x-axis, but is going to be wider than -1 over 2x squared, because 1 over 4 is closer to 0 than 1 over 2. Good. So there's our 4 parabolas for this section. Make sure you have those drawn on your investigation and fill out those accompanying cells. So just pause the video at this point and complete those sections. Okay, now let's fill out what we've discovered about the a value, about varying the a value of a quadratic function in vertex form, sorry. So a represents, let's get these technical terms right, a represents the vertical stretch or compression. Okay. By a factor of a. Make sure you have this written just like this when you're describing a transformation form. A represents the vertical stretch or compression by a factor of a. So a stretch is when it gets narrower, and a compression is when it gets wider. Okay? When a is, we also discovered that when a is greater than 0 or a positive number, so if we look back when y was positive, as in y equals 2x squared or 4x squared, the parabola is opened up. But when a was negative, like for this one with -1x squared and -2x squared, the parabola is opened down. So we can summarize that by saying when a is greater than 0, the parabola opens up. But when a is less than 0, the parabola opens down. Now, let's also consider the fraction values of a. Okay, fraction values of a. Oh, first let's do we'll do fractions after. Okay, scratch that. So when a is greater than 1 or less than -1, so in these instances, 2 is greater than 1, 4 is greater than 1, and in this instance, a is -2, which is less than -1. So in these instances, remember the parabolas were all stretched. Okay, so when a is greater than 1 or less than -1, then the graph is stretched vertically. Stretched. It's stretched vertically or it narrows. Okay, but when you describe it for me on an assignment or a test, I want you to say it is stretched vertically by a factor of whatever the a value is. Good. We also looked at what happens when the a value is between 0 and -1. and between 0 and 1. Okay, we did that in this section here. 1 over 2 is 0.5, which is between 0 and 1. 1 over 8 is between 0 and 1 as well. Negative 1 over 2 is between 0 and negative 1. Negative 1 over 4 is between 0 and negative 1. Okay, so these are the instances when we considered values that are not 0, but are between negative 1 and 1. Okay, if that was a lot to take in just a couple seconds there, rewind it and listen to me say it again, just so you can understand what values of A we're talking about. We're talking about values of A that are between negative 1 and 1, but are not 0. So they will appear as fractions. Okay? So when A is between negative 1 and 1 and not 0, the graph is compressed. Vertically. Or you can think of it as it widening. But make sure, again, you describe it as the graph is compressed vertically by a factor of whatever the A value is. Okay? Good. So, if we then kind of just summarize everything we learned today, remember you should have this filled out on your placemat. If we just let's just briefly summarize everything we learned. So, here's the vertex form of a parabola. Okay? We noticed that when we varied the value of k, if k was greater than 0, so if k was positive, the parabola moved up. But if k was less than 0, so if it was a negative number, the parabola moved down. Okay, so this is the graph of x squared plus 4. This is x squared minus 8. We also learned that when we varied the value of h, if h was greater than 0, the parabola moved to the right. But remember, it's going to look like this. Okay? This is the parabola that has moved to the right. X minus 7 squared is moving 7 units to the right. Because the h value is 7. The h value is positive 7 in this case. Positive 7 is greater than 0. Because we substituted positive 7 in for this h value. Good. And if h is less than 0, as in this graph here, so x plus 7 squared moves to the left 7. And we know this is a negative h value because if we plugged in negative 7 for h, we plug in negative 7, that is equal to x plus, I can write that better. That's equal to x plus 7 squared. Okay, so the h value is negative 7 for this function, and it appears as x plus 7 squared, because when we subtract a negative, it changes to a positive. So when h is greater than 0, the parabola shifts to the right, so x minus 7 squared shifts to the right. When h is less than 0, so when h is a negative number, even though it will appear as addition, that h value is a negative number for this reasoning. So when h is less than 0, the graph is translated h units to the left. Okay, so for x plus 7 squared, the graph shifts 7 to the left. So the vertex has moved 7 units left on the x-axis. Good. Now let's review the last one, the a value. And I thought it was kind of neat when I graphed all of these a functions. To me, that looks kind of like a Spider-Man symbol, kind of neat. Anyways, so what a does is it vertically stretches or compresses the parabola, depending on the value of a. Also, if a is a positive number, if it's greater than 0, as in these three functions here, the parabola will open up. But if a is less than 0, if it's a negative number, the parabolas will open down, as in these three parabolas here. Okay? So, also we learned that if a is between 0 and negative 1, or between 0 and 1. So if it's these fraction values, the parabola is going to be wider than the graph of y equals x squared. So the parabola is going to get wider, or the technical term, compressed vertically by a factor of a. If a is greater than 1, so if it's 2, for instance, or if it's less than -1, so if it's -2, the parabola is stretched vertically by a factor of a. So that's all we have learned for today. Make sure you have your investigation completed and you have your placemat filled out. On the next day, we'll fill out this section here for the usefulness of vertex form, and we will work with graphing parabolas when we are given the equation of a parabola in vertex form. Okay? And we'll see why having it in vertex form is useful for doing that. Okay, thanks for watching. Please leave any comments that you need if you have any questions about anything, and thanks for watching.